Well, hello and welcome to this video. We are going to talk about how to solve problems that have radicals. Okay, so our radical equations. Now, we already visited a little bit about inverses and how to do the inverse of a quadratic. So remember, we just said that the inverse of an x squared is a square root. That's how we undo one. So in other words, to undo an x squared, we would square root both sides. To undo a square root, we would square both sides. So that is what we're going to look at here. So we're just going to do some examples for you real quick. So the first one, very simple one, if I have the square root of x equals, let's say 2, the step would be then to square both sides, and therefore x equals 4. And you're done, okay? Radicals are definitely easier because we don't need to worry about having two answers. We just say the square root of 4 is 2. 1, because we know we can't put a negative 4 in there. That would not give us 2. So there's example 1. Example 2. If you have the square root of x plus a number, we'll do 4. And we're going to say that equals, I'll give you an easy one, 8. So you are going to solve for your square root first. Now we are going to square both sides, and x would in this case equal 16. Okay, next example. If I have, I'll give you an extra step in there, and let's do 8. Let's make it a little bit more complicated. So again, we are going to solve for your radical. So I'm going to add 3. At 11, I'm going to divide off the 2. Square root of x equals 11 over 2. So again, the same thing. I am going to square both sides. So x would equal 121 over 4. And again, you could place that back underneath your radical and check it out. Next example, okay, is what happens if I have then something underneath the radical. So let's do x minus 1 equals 3. Again, we're going to square both sides. And guys, if you'll notice, I am putting parentheses around the radical each time because I am squaring that whole thing. And again, a lot of times you will see me come up here and I'll just cancel those two because those two things are canceling. So the same thing here, your square and your square root cancel, and you're always left with what's underneath the radical. Okay? It doesn't matter whether it is a single x, whether it's a number, whether it is an expression like x minus 1, or it could be a polynomial, whatever it is, that's what you're left with. This is equal to 9. Go ahead and move your 1 over, and x equals 10. And again, guys, I could do a quick check. 10 minus 1, so that is the square root of 9, which is 3, and it does check. Okay? Next example. Again, we're just going to add a little bit more to it every time. So now I have the square root of x plus 2, and then I'm going to have plus 3 equals 5. Now, a lot of times when you see this problem, just FYI, they will put that 3 in front. Same problem. What that does is by putting the 3 in front is makes you realize that that 3 is not underneath the radical. So those are exactly the same problem, same steps on solving them. So you would minus 3. I'm going to square both sides. And then move my 2 over. And I'm done. And again, I could check that if I wanted to. Okay, let's give you another one. Got just a couple more and we'll be done. So we're going to put a number out in front. Let me go ahead and make this one just a slight bit harder. So we're going to go ahead and let's put -5 here. Equals 7. Let's do that. Okay, so again, remember all the time I'm solving for my radical piece of it. So I'm going to add 5. I am going to divide off the 3. I am now going to square both sides. And move the 1 over. And I'm done. Okay, now let's do what happens now. So all of these, I've only given you one radical and it's on one side. What happens if I have 2 radicals? Okay, so maybe I have the square root of x equals the square root of 3. Okay, the same thing, I am still solving for this piece of it. So I'm going to square both sides. X equals 3. That one's a pretty easy one. Okay, but what happens if it gets harder, in which I have the square root of x plus 1 equals the square root of 3. Okay, same thing. I'm going to square both sides. So x plus 1 equals 3. X equals 2. Okay, again, not too hard. What happens if I have variables under both radicals? Okay, now I'm making up some things here, so we'll see how they work. Again, I'm going to square both sides. So I have x plus 1 equals 2x minus 3. I'm going to go ahead and solve. I'm going to move it this way because I want to have my x's positive. And it looks like x is 4. Now, when you start getting them where they are, especially the radical equal to the radical, not so much on the first two because they were equal to numbers, but especially when I get to this third one, you do need to always check because it is possible that we could get, again, our extraneous roots. Okay, again, remember extraneous roots are answers that we get, but once we put them back into the equation, they don't actually work. We had those when we did absolute values, and especially if you had an absolute value equal to another absolute value, it was definitely possible you could get an extraneous root. That could also happen here. So once you are done, you need to check your answers and make sure that it does work. Okay? Again, that one's not too complicated. But let me give you one more. Okay? So what if I have a radical, and then I happen to have, and I'm making this one up again, another radical. Okay? This is where it gets to be a little bit more complicated. And we actually have multiple steps that this one has to happen. One of the things you cannot do, let me rephrase that, you cannot do is you cannot square each individual one. Okay? If you will remember, when we did this, each time we squared both sides. Every time we squared both sides. So when you come here, you must square both sides. Okay? Well, on the right, that's not a big deal. This square and square root are going to cancel. Okay? But on this side, we have to go back to the rule that we have that if it is something squared, it is actually that times itself. And we are going to need to do a FOIL here. Okay? So watch what we do. When we do the first, well, this one is just the square root of x plus 2 times the square root of x plus 2. That's the same thing as squaring it, so I'm going to just get x plus 2. Okay? That looks great. When I go to do the outside, now I have this one times this one. So I'm going to get the square root of x plus 2 times the square root of x plus 2. Okay? When I go to do the inside, I now have another square root of x plus 2. Oops, that's supposed to be, one of those is supposed to be a 1. Change that to a 1. Times the square root of x plus 1. Equals, whoops, not equals yet. I forgot to do the last. Last, which would be the square root of x plus 1 times the square root of x plus 1, which is x plus 1. Wow. Is that a mess? Now, this is going to give me, when I combine like terms, I have 2 of the square root of x plus 2 times the square root of x plus 1. And then I have 2x plus 3, and we're actually look like we're making it worse than we're making it better. I'm going to go ahead and move this piece over to the other side. So minus the 2x, minus the 3. Okay? Next step is we're going to get rid of the 2. And this is 1/2 x plus 1/2, if you want to do it that way, or I could leave it. Now, this here, again, because the fact that both of those have to be positive, I can now actually square that, or FOIL it, x squared plus 3x plus 2. Okay, I am just foiling what's inside there. 1/2 x plus 1/2. Wow, that's a lot of work. Square both sides. Now then I can get rid of radicals. So I have x squared plus 3x plus 2 equals, and now I'm going to have to square this. So you can go over to the side and square it, or if you, so 1/4 x squared, that would be what? Plus 1/2 x. You guys can double check that for me, plus 1/4. Okay, and we're going to set it equal to 0. Okay, now if you want, it might not be a bad plan to go through and multiply everything by 4 just to get rid of fractions. So I'm going to do that. 4x squared plus 12x plus 8, and multiplying everything by 4 equals x squared plus 2x plus 1. And now I'm going to move this together. 3x squared, set it equal to 0, plus 10x plus 7 equals 0. And I would, at this point, and probably the video is getting a little long, I would need to either factor, run the quadratic, which I think that one will factor. Will it factor 21, factors of 21, that'll give me 10. That'll be 7 and 3. So it will factor. Okay, so 3x plus 1, x, whoops, no, 3x plus 7, right? Try that. X plus 1. Yep, that works. Okay, and so x equals a negative 7/3 and a negative 1. Okay, now I've got answers, guys, but here's the thing. You got to go back up here and check it to see if it works, because you might have a negative under the radical. So if I put a negative 1 in, will it work? So what I'm looking for is to make sure it doesn't give me a negative. Okay, so if I put a negative 1 in, let's do a quick check. This is going to be the square root of 1. If I put a negative 1 in, that's the square root of 0. So that is 1 on this side. If I put in a negative 1, I get 1, which is 1. And voila, negative 1 does work. Now I would need to do the same thing for 7/3. Now that's going to be a little trickier because I'm going to need to run my calculator. I don't have it on me right now. So you could double check that. So your question would be double check to make sure negative 7/3 works by substituting it in. And let's say a negative 7/3, maybe we can just think of it real quick and see if it does work. So that would be a negative 2 1/3. That is not going to work. And the reason I know that is because when I put in here a negative 2 1/3 plus 2, this gives me an imaginary number right there. So this is an extraneous root. So I could check that. Okay, I think my video got a little long on there. I apologize. That would be the worst that you could do on a problem. So that would be the hardest that you would see. I will tell you that there is sometimes one of those is on the test. Okay? Okay, so good luck on doing square roots and solving them. Again, we can go from something obviously very, very simple to something very, very complicated. Again, the key is when you do have a radical on both sides, you must check for an extraneous root.